Welcome friends to my YouTube channel. Now on my last lecture I have told about the moment of inertia of a sphere, solid sphere, about its own axis, that means about a diameter. Okay. Now in today's lecture I shall going to take another example, that is I shall discuss the moment of inertia of a solid cone. Okay. So say this is a cone and this is its vertex. This is the base, this is the vertex, say O. Okay, so say this is the radius of the cone, say this is R. Now about its own axis of symmetry, that is this axis. Okay, now we all know that the cone consists of so many circular discs. We all know that a cone consists of so many circular discs. So we take such a disc, okay, say of radius x, okay, and width, say this width is dy, that means the distance of the center of the disk from O is y. Okay, so the cone consists of large number of disks, so we take such a disk of radius x and width dy. Why dy? Because this is dy and the distance of the disk from the center is y, so if this is y, this width is dy. Okay, so we take a disk of radius x and width dy at a distance y from the vertex. Okay, so okay, and the total height is say h. Okay, so you imagine that rho is the mass per unit volume. Okay, so what is the volume of the disk? So volume of the disk is simply area into thickness. Area is pi x square and thickness is dy. So this is the volume of the disk. Okay, so mass of the disk is what? Mass of the disk pi rho x square dy. Okay, fine. Now what would be the moment of inertia of the disk about its own axis? Okay, the disk looks like this. Okay, and this is the axis. So we have calculated previously that if this is the distance r, so moment of inertia of a disk about its own axis is half mr square. Okay, that is, the axis is perpendicular to the plane of the disk, or you can say about its own axis. So moment of inertia of the disk. Okay, so if I call di, so this is simply okay, mass into half mr square. Okay, so that means half, what is m, pi rho x square dy, and what is x? That is the distance of the axis is x, so that means x square. So half pi rho x to the power 4 dy. Okay, pi rho x to the power 4, pi rho x to the power 4 dy. Okay, okay, just simple. At first find out the area of the disk, that is pi x square volume of the disk pi x square dy. Rho is the mass per unit volume, that is mass of the disk is this. So moment of inertia of a disk about its own axis half mr square. So here we take at first the elementary disk, so half m x square. 5 half pi rho x to the power 4 dy. Okay, so now from this is a small triangle and this triangle. Okay, that is, say if you give a name OABCD. Now you take these two triangles OAB and OCD. Okay, this by this, that means x by r, this by this, that is y by h. And here say x is what, y r by h, say. Okay, so what will be my di? My di will be half pi rho x to the power 4 dy, that means y to the power 4 r to the power 4 by h to the power 4 dy. Okay, now we can easily integrate this. So between 0 to h, because the entire height of the cone is h, so moment of inertia of the entire cone about its own axis is what? This is simply 0 to h, half pi rho r to the power 4 by h to the power 4 y to the power 4 dy. Okay, so half pi rho r to the power 4 by h to the power 4, this is simply h to the power 5 by 5. So 1 by 10, this is pi rho r to the power 4h. Okay, we do simple geometry. So you have to practice these things, otherwise it is too difficult to recall the formulas if you don't practice it. Okay, so at first you have to practice this. So we can rearrange it, that is 1 by 10 can be written as 1/3 3 by 10 pi r square rho h into r square. So 3 by 10, what is this? 1/3 pi r square h, this is the volume of a cone of radius r and height h, and this is rho is mass per unit volume, that is mass of the cone. So 3 by 10 mr square. Okay, so this is the moment of inertia of a solid cone. Okay, so this is simple. Now another thing, let us try to find out the moment of inertia of a rectangular plate. Rectangular plate about any, say, diagonal. Interesting thing, just see. So you just draw a rectangle. Okay, say this is A, B, C, D. Say length is L and breadth is B. Sorry, this is L and this is B. Okay, so if we consider a rectangle, you see that this rectangle, the diagonal divides the rectangle into two triangles. Okay, that means the mass of the rectangle is equal to the sum of the masses of two triangles, no doubt. So if we can say that the mass of the rectangle is m, then the mass of the triangle is what? Single triangle is m by 2, obviously, because the rectangular plate consists of two triangles. Okay, so if is the mass of the rectangular plate, then the mass of the single triangle is m by 2. So at first, so it is clear that in order to find out the moment of inertia of the entire rectangle about any diagonal, we have to find out the moment of inertia of the triangles. Okay, about this axis. So we have to draw a height, that is h. This is also h. So if this is h, this is also h. Okay, this is e, this is f, say. Okay, so at first, what will be the area of the triangle ACD? What would be the area? that is half into CB into AE. So half into what is CB? This is L, this is B. That means CB means L square plus B square whole to the power half. And A is, we assume, half. Okay. Now similarly, what is the area of the triangle CBD? This is also same. Half into L square plus B square whole to the power half into H. Okay. So we can write this half into L square plus B square whole to the power half into H. Now from the figure we can write the area of ABCD. This simply equals to area of triangle ABC plus area of triangle CBD. Now what would be the area of the rectangle L and B? That is simply LB, and 2 into half into L square plus B square whole to the power half into H. So from which H is what? LB by L square plus B square whole to the power half. Because we have to find out, we must have to know H in order to calculate the moment of inertia of the triangles. Because we know that the moment of inertia of a triangle about any of its sides is half mh square. So this H we have to find out in terms of known quantities, that is L and B, that I did. Okay. So remember that the value of H is LB by L square plus B square whole to the power half. Okay. Now at first, the entire mass of the rectangle is M. So mass of a triangle, mass of a single triangle is obviously M by 2. Okay. So what will be the moment of inertia of the triangle ABC about BC? ABC about BC, that means half, 1/6 mh square. 1/6, we can put M by 2 instead of M, because the mass of a single triangle is M by 2. H square, that means LB by L square plus B square whole to the power half. This is H and this is, that means 1/12 M L square B square by L square plus B square. Fine. Now similarly, what would be the moment of inertia of the triangle CDB about CB, any diagonal? That is 1/6 M, mass of the triangle is M by 2, H square. That means LB by root over L square plus B square whole to the power half. That means M by 12 L square B square by L square plus B square. Fine. Now what would be the moment of inertia of the entire rectangular plate about the diagonal BC? Just you add the two terms, that is M by 12 into L square plus B square by L square plus B square plus M by 12 into L square B square by L square plus B square. That means M by 6 into L square B square by L square plus B square. So this is the answer. Moment of inertia of a rectangular plate about any of its diagonals. Okay. So at first you have to consider it as the sum of two triangles, and from symmetry consideration you can easily find out the moment of inertia of two triangles, and then adding these two we can get the result. Okay. So if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Okay. The link of this video will be given in the description box. Okay. So if you have any query, then just write it in comment section. Okay. Thank you.